concepts about spectral photometry. Okay, puro terms lang tayo today. So, kahit basahin niyo yung PowerPoint, may masasagot kayo. Okay? So anyway, let's proceed. I'm not going to use my iPad to draw kasi puro ano lang to, puro concepts. Okay. So let's get started. Okay. So hopefully in your lecture, you were able to discuss spectrophotometry na, no? Hopefully nadaanan nyo na because kung hindi pa, medyo magagahol kayo sa time, no? But yun. So in your lecture, ano sinabi doon about spectrophotometry? This method of chemical analysis is used uh, to quantify substances based on how they interact with light. Okay? So apparently kasi, yung light natin, they interact with matter. Okay? So before, noong lumang panahon pa, before 19th century, they don't believe in that, no? However, there are certain problems in physics that led to the belief in the interaction of light and matter. Okay? So, una nangyari, sabi lang ni Maxwell, no, that light is an electromagnetic radiation, no. However, according to several physicists including Albert Einstein, apparently light can interact with matter, no? Especially in the discovery of the photoelectric effect, no? So nangyari doon, kapag inilawan mo daw yung bagay, yung electron tumatalsik, no? Yun yung photoelectric effect na sinabi ni Albert Einstein. And doon siya nanalo ng Nobel Prize, no? Hindi sa relativity. Okay. Kasi relativity, it wasn't proven just recently lang, no? Last 2019, dun lang siya hindi, 2020, dun lang siya na-prove, no? Dun sa picture ng black hole. But yun nga, ano ba nangyayari when light interacts with matter, no? So according to your lecture, light can absorb, no? Matter can absorb light, no? Okay? And it can also reflect light, no? Okay? So for example, itong red object na ito. For example, this red button here sa aking LED light. So this red color is actually the transmitted color, no? Yung red na yan, nakikita ko yan as red kasi yan yung nire-reflect niya na ilaw. Ang ina-absorb niyang ilaw or light is the complementary color, no? Yung katapat niya sa color wheel, no? So ang katapat ni red sa color wheel ay green, no? So it absorbs green color, but it reflects red color. Kaya na-perceive natin yan as kulay red, no? Okay? So yun yung idea. So yung concept na yun, ginagamit yun sa UVVs, no? Okay? So when you pass through a certain wavelength, no? It will absorb, the sample will absorb that wavelength, no? Okay? And based on the absorption of the wavelength of light, no? Ayan, you can quantify chemical substances. Okay? So basically, yun lang yung concept ng lecture. No? But for now, we will just focus on the additional concepts, no? Additional terms, and of course, yung how do spectrometers work. No? So yun lang di-discuss natin today. Puro concept lang. Okay? So, let's talk about the instruments used in spectroscopy, no? So ito yung magiging flow ng ating discussion today. We will look first into the instrument components, ano yung mga parts niya, what is UV vis spectrophotometer, ano yung single double beam spectrophotometer, and what are infrared spectrophotometers. Okay? So, yan lang di-discuss natin for today talaga, no? Puro terms lang. So, it will be better if you open your PowerPoint with you, no? Wag na kayo mag-notes. So, let's work with some terminologies muna, no? So, when you say spectroscope, no? Meaning ng scope, this is used to observe, no, the spectrum of light, no. So ito yung mga devices in which we can see the colors, no, emitted or emitted by objects, no. So yan. So yan. Para siyang microscope, no? Kasi kapag microscope, you are seeing small objects, di ba? But for spectroscope, you are observing the spectrum of light, no, that is emitted by an object, no? Okay? So for example, may apoy, no? Pag tinapat mo yung spectroscope mo doon, makikita mo yung spectrum of light, no? Okay? Yung mga colors na, iba pang colors na pinapakita niya or nilalabas niya. Okay? So yun yung spectroscope. This is a precursor to our modern instruments nowadays. Okay? So yan yung mga ginagamit ni Isaac Newton, no? According to the lecture, 'di ba si Isaac Newton na discover niya that light is composed of spectrum of colors, no? Using spectroscope, no? So in the middle you have the prism there, no? So the prism will diffract light, no, according to their corresponding wavelengths, no. Okay? So this is a precursor to our modern technology na, no. So this is precursor to everything we use in the lab na, no. Okay? So next one we have this term colorimeter, okay? This thing will be used in your field, no, pag nag-work na kayo. Kasi, for example, if you do urinalysis, no, you will be dealing with colorimeters a lot, no. So, ano ba meaning ng colorimeter? Meter meaning measurement, color meaning color. So, it measures the color, no. Yun. So, yun lang yung purpose ng colorimeter. So, depending on the intensity of colors, it can quantify the chemical substances present in your sample. Okay? So, let me give you an idea kung saan ginagamit yan sa urinalysis, no? Okay. So, onti lang yung alam kong test sa medtech kasi hindi naman ako medtech, no? Kaya paulit-ulit yung example ko. Pero at least, di ba, natututo din ako sa field nyo. Anyway, so this, when doing urinalysis test, no, when quantifying substances here, you actually submerge one of this test strip, no? Nilulublog mo yan sa urine. And then the colors will change, no? Okay? So to accurately, actually yung concentrations nila, pwede mo naman siya ma-visualize, no. You have this color palette here with their corresponding interpretation. However, when doing laboratory analysis, no. Mas maganda kung mas accurate yung makukuha mong number, no. Kasi makukuha mo pag visual lang is approximate lang, no. Kunwari, what if somewhere in between yung color niya? Ano yung concentration ng ganong metabolite, no? So, may bias, no? Ganon. Baka sabihin, ay, favorite color ko yung brown. So, ito yung amount ng uric acid, no? So, to minimize that bias, no, in the laboratory, which we will be using in the future, you will use colorimeters, no? So basically, ang gagawin nyo dyan is, this is your test strip, lulublob nyo yan sa urine, then magbabago yung colors nila. Magbabago yung intensity ng colors na. So what will happen is that, after yan ilublob doon, ayun, ipapasok mo siya sa colorimeter. Okay, let me show you kung ano itsura ng colorimeter. Ayan, no? So this is the common colorimeter used in medtech. Ito, medyo nakakita na ako nito. Okay. So ayan, gagawin mo lang dyan yung test strip na ginamit mo sa urinalysis. Papasok mo lang doon. And then the instrument will read kung ano yung color intensity, kung siya ba ay masyadong matingkad or what. And then from that info, makukuha niya yung concentration accurately ng metabolites in your urine. Okay? So, yun yung purpose ng colorimeter sa inyong field. No? Okay. So, again, colorimeter, this is an instrument used for absorption, measurement, with the human eye as detector. Okay, so ginagamit lang to to measure yung colors ng ating sample, no? Okay, so yan. So pag photometer naman, so meter meaning measurement, no? Photo meaning we are measuring the light na, no? So we are dealing now with the electromagnetic properties of light, no? Okay? So there are many photometers available in the laboratory, which is for now will be abstract lang, pero pag nag face-to-face classes na tayo, may encounter nyo na sila, no? So for now, idea lang muna tong mga to. Okay. So examples of photometer we use in the laboratory are UV, visible, or infrared radiation photometers, no? Okay. We also use photometers for fluorescence material. For example, yung tawag dun sa laruan na yun, yung glow stick, no? Okay. So glow stick is a fluorescent material, no? It exhibits chemiluminescence kaya siya nagkukulay, no? Okay. So there's also a photometer for that called the fluorometer. Okay. So yun lang. Okay. So ito basically ang idea pag photometer, you are now measuring the interaction of light with your particles, no? Ayan. So it uses photoelectric current, no, to quantify accurately those stuff, no. Okay. So mangyayari doon yung light emitted, no, or absorbed by our chemicals, no. When it hits the detector, nagkakaroon ng voltage, no, nagkakaroon ng cell potential. Okay. So ganun. So, and based on the cell potential, they can identify the concentration. Okay? So yun lang yung idea niya. Para siyang pH meter lang din. However, this time hindi ions yung dinedetect niya, rather they are detecting light, no. Okay? A certain wavelength of light. Okay, so spectrograph, no? So this is a graph, no? Literal graph yan, showing the spectrum of colors, no? So depending on the elements you have, no, you will have different spectra, no? Okay. So for example, if you have hydrogen, iba yung spectra niya with neon, no? So hydrogen medyo yellow yan, no? Pag neon kinda orange, no? Okay? Iba rin yung spectra ng helium. Helium is quite purple in color, no? So yan. So iba-iba yung colors nilang ng kada element, no? So you can actually identify elements based on the colors they exhibit, no? And yun yung ginamit ni Niels Bohr to prove his idea sa physics, no? Which is di ko na i-discuss kasi na yun. Kasi quantum mechanics na yun. Pero ito yung idea na yun. Pakita ko lang. So according to Niels Bohr, each element have their certain spectra, no? And that is what we use nowadays, no? Almost a century past, no? Yan yung ginagamit natin to identify elements sa labas ng Earth, no? For example, if you look at a star, you can quantify or you can tell kung anong elements andon just based on the spectrum of light it emit, no? Okay. So, yun lang. So, kasi siguro nagtataka kayo na paano kaya nila nasabi na yung star ay 99% hydrogen, something percent of helium, something percent of carbon, okay? So, yung mga ganong idea ay ay sa tulong ng spectrometer, no? Just remember that yung ating light, they interact with matter. And it is they have they have characteristic colors, no, per element. So from that we can identify the elements. Okay. So spectrometer, okay. So ito na daanan na natin to kanina. So when we say spectrometer, we are measuring the spectrum of light, no. Basically we are determining the quantities of light, no, of certain wavelength, no. So this is used for absorption, emission, and fluorescence measurements, no, which is somehow nadaanan na siguro sa lecture niya. Okay. And a spectral photometer, this is the instrument na, no? So, parang ito lang din yon with, with additional device called the phototransducer, no? In which it converts light to electrical energy. Okay. So, mangyayari kasi doon sa spectrophotometer, yung light pupunta siya sa detector, and once it hits the detector, that that light will be converted into a current, no? So, depending on the current, pwede na ma-quantify yung ating chemicals, no? Okay? So, yun lang. Okay, so yan yung mga terms na kailangan ninyo, hindi naman kailangan makabisado, no? So, you have to be familiar lang, okay? So, okay. So, yan lang yung mga terms natin. Take note of the differences, no? Okay, so, lahat sila may ope sa dulo or may meter sa dulo. Pag basta sinabing meter, ibig sabihin, measuring device yon. Okay? So, yan. Okay. Pag graph, ibig sabihin, graph yan. Okay? So, ganun lang. Okay. So, ano ba yung mga modes of spectroscopy, no? Ano ba yung mga ways natin to quantify substances based on their interaction with light, no? So, maraming uri ng spectroscopy. One of which is the emission spectroscopy. Okay. So, ano yung kwento ng emission spectroscopy? What will happen here is that your analyte uh, will be excited, no, by the addition of heat or electrical energy. So basically, gagawin mo dito is iinitin mo yung sample mo. Okay. So once you heat your sample, it will start to glow, no? An example niyan. For example, yung bakal, apoyan nyo. Ano nangyari sa bakal kapag naapoyan, 'di ba nagkukulay red siya? Yun. So that is emission spectroscopy. If you study that in-depth, emission spectroscopy tawag doon. Okay? So ganun yung matter natin, no? For example, in my thesis nung undergrad, I quantified lead, no, using emission spectroscopy. Yung lead, that is a metal, no, and it emits certain wavelength of light, no? So I think hindi siya kulay red yung ini-emit niya. I think medyo green yun eh. Based sa pagkakaalala ko, no? Medyo green yung color na ini-emit niya. So depending on the intensity of that green color, no, the sample emits, you can quantify them, no? So the higher the intensity of the color, that means the more concentrated your species is, no? So, sayang wala akong picture nung nag-test ako nung dati nung undergrad, no? Kasi ginawa ko doon yung mga lead samples ko, which is toxic. Yan. So, depending on the concentration, nagbabago yung intensity ng kulay na green, no? So, yun yung emission spectroscopy. Basically, you are adding energy to your sample for it to emit light, no? Okay. Siguro tataka kayo, no? Paano siya nag-i-emit ng light, no? O remember, yung ating Gen Chem, ay nag-quantum numbers tayo. Di ba alam natin yung electrons, they fill certain orbitals, no? Medyo pangit sulat ko kasi wala ako sa iPad ngayon. So, for example, this is the electron, this is the energy levels, no? When you add wavelength of light, no? Ano mangyayari dyan? Tatalon yan to a higher energy level. And once it returns back, no, mag-e-emit din yan ng color ulit, no? So basically, gagawin mo dyan, you will add energy sa sample mo so that the electron will be excited to a higher energy level. So, yun yung addition ng energy. So, pwedeng by heat or pwedeng by electrical energy. So, pag ininit mo yon or pag tinaasan mo yung kuryente niyan, ma-excite yung electron. Tapos, syempre, anything na na-excite ay magre-relax din. So, pag nag-relax yung atom, dun siya nag-emit ng color. Okay? Dun siya nag-emit ng characteristic wavelength niya. Okay? So, depending on gaano karami yung intensity ng in-emit niyang color, then you can quantify your sample. Okay. So next one will be the absorption spectroscopy. Okay. So in absorption spectroscopy, medyo similar lang din to, no? Okay. So, ang nangyayari dito is that you have an incident radiation. Okay. So, typically this is light, no? So, yung light, papadaanin mo siya sa sample mo. And then, the sample may absorb that light, no? So, ibig sabihin, onti na lang yung matatransmit niya at the end, no? Bakit, no? It has something to do with electrons then, no? Suppose these are the energy levels. Okay. Yan. So, kunwari, pinadaanan mo yan ng light uli, no? It will absorb energy, no? So, tatalon siya to a higher state, no? So, once this sample absorbs energy, ibig sabihin, onti na lang yung tatagos na light sa kanya kasi yung iba inabsorb niya eh. Okay? So, one good example of this is yung mga translucent materials or yung mga colored materials, no? 'Di ba kapag nag-pass through kayo ng light sa colored samples nyo, hindi na ganun kaliwanag pagdating sa kabila, no? So, ganun din ginagawa sa absorption spectroscopy. So, basically, we can visualize our samples as translucent material wherein it absorbs some of the incident light, no? And it will transmit just a few of the incident light na lang. Okay? So, para siyang translucent film, no? Okay. So, para siyang translucent film na i-absorb niya yung ibang light, tas onti na lang yung tatagos. Okay? So, depending on how much, no, the transmitted radiation was reduced, no, depending kung gaano na lang kaunti yung nakatagos sa sample mo, then you can quantify your amount of sample. Take note that in the lecture, naturo dito yung Beer-Lambert's law or the Beer's law. Medyo pangit sulat ko ngayon. Okay, so take note that in this topic, you know the Beer's law, wherein absorption is directly proportional with the path length and the concentration. So it means if marami siyang ma-absorb na incident light, no, mataas concentration niya. Okay? So, ibig sabihin, kapag marami kang sample, maraming incident radiation yung i-absorb nila. Okay? So, marami yung absorb. Mataas yung absorbance niya. Okay? So, from this equation, you can do calculations, no, using linear regression, which I believe was discussed in your lecture na. If hindi pa, no, you can watch my lecture video na upload ko na naman siya sa YouTube. Okay? So, yun lang. In photoluminescence naman, okay, so ito ay parang combination of the two, no? Para siyang absorption and emission at the same time, no? So, ganun din yung idea dito. When your sample absorbs the light, no, it glows, no? Okay. So, other than it absorbs the light, nag-glow din siya, no? Okay. So, one example of this is the glow stick, no? So, yan. So, yung glow stick, nag-absorb yan ng energy from the surroundings and sa chemical reaction, no? So, yan. So, the absorbed energy from those sources, no, yung chemical reaction inside and the heat from the environment, no, it helps the material to glow, no. So it helps the the chemiluminescent sample to glow. Okay, so ganun din dito. Okay, but yan, hindi ko masyado to na encounter during my undergrad, no. Ang common kasi is the absorption or the emission. Okay. So, basically, kapag photoluminescence, parang pinagsamang dalawa lang siya. Okay. Okay. Pinagsama siyang emission pati absorption. Okay. So, yung sample mag-absorb ng light, pero at the same time, mag-emit din siya ng light. No? So, parang you are measuring two parameters at the same time. Okay. So, this is true for glowing objects, no? So, for example, you want to measure yung mga nasa tutubi, no? Tutubi ba yung lumiliwanag? I don't know. Hindi ko lumalabas eh. Basta yun, yung mga lumiliwanag-liwanag na animals. No? You can quantify the concentration of those chemicals in them using photoluminescence. Then, ayun. So now ayun, nadaanan na natin yung mga four types of spectro analysis, no? So, proceed na tayo with the components. So, basically, parts lang pag-uusapan natin, no? May mga similarity yung mga components na to. Okay? So, we will not discuss this in-depth, no? Kasi kapag diniscuss natin to in-depth, baka maka-perfect kayo sa board exam ng chem. So, ayan. Ganito kasi yung mga questions sa board exam namin. No? Medyo mahirap to, actually. Okay? So, pero yun, dadaanan lang natin sila. Let's look at the similarities and the differences. Yun lang gagawin natin for now. Okay? So, yan. So, in absorption spectroscopy, this is how the circuitry looks like. No? So, ganito yung itsura ng ating diagram. No? Okay. So, of course, you have to have a source. No? Bakit ka may source? Because this will be your incident radiation. Okay? So yung source na to is typically lumiliwanag yan, no? Para yung bumbilya. Okay. Later on, madidiscuss natin ano-ano yung mga uri ng bumbilya na ginagamit namin. Okay. So basically, you have a lamp there. And you know that lamp emits all types of radiation. All spectrum of radiation. Okay. So, since halo-halo yung wavelength dyan, you have to choose a certain wavelength na. Okay? So, kailangan dun sa lahat ng ilaw na ini-emit niyan, mamili ka lang ng isang wavelength using a wavelength selector. Okay? So, again, ito, lahat ng types ng ilaw i-release niya. Ang purpose nito is to select just a certain wavelength. So, parang ito yung prism natin. Okay? So from white light, magiging separated sila, segregated by different colors na, no? By different wavelengths. And then the chosen wavelength, no, for your analysis will pass through the sample and your sample will absorb some of them. Okay? So basically, ito yung incident radiation. Ito yung nangyayari sa kanya. So from white light to a certain wavelength, and then that incident radiation will be absorbed by the sample. However, not all of it will be absorbed, no? Meron pa ring tatagos, no? Okay? And that transmitted radiation will be detected by the detector. Okay? So, detect niya kung gano'n na lang kaunti yung, yung nakatagos sa sample, no? And by measuring kung gano'n na lang karami yung, na-transmit after the wavelength pass through the sample, then it will report the readout sa computer. Okay? So, i-report niya, ito yung concentration niyan. Okay? So, ganun. O kaya, if hindi advanced yung technology mo, ikaw pa magma-manual solve ng concentration using the Beer's law. Okay? So, yung mga advanced absorption spectroscopy devices, yun, kaya na nila i-report agad yung concentration. Pag fluorescence naman, medyo similar lang yung process. However, the light source has to be perpendicular with the sample. It has to be perpendicular with the detector. Perpendicular meaning naka 90 degrees, no? Okay? So, hindi pwede siyang, parallel, no? Hindi siya pwedeng 180 degrees from the light source to the detector. Kailangan naka perpendicular. Okay? So, ang gagawin kasi nito is, di ba, remember, fluorescence to. When you pass through an incident wavelength dito, mag-glow yan. Okay? So, for you to accurately measure gano'n siya nag-glow, kailangan naka-perpendicular to, no? Para hindi dumagdag yung color nito, hindi dumagdag yung light nito. So that yung detector, ang malalaman lang niya is kung gaano karami ito nag-glow. Kasi kung imagine mo, andito yan, imagine mo kung andito siya, wait lang, ayan. So imagine mo kasi kung nandito yan, ang mangyari, mag-a-add up yung light intensity na ito, pati ito. Okay. Kasi ito mag-glow, di ba? So mag-a-add up yung kanilang intensity. So pangit yung makukuha mong result, no? So again, take note of that. The light source has to be perpendicular so that it will not interfere with the measurement, no? Okay. So para yung madedetect lang ng ating instrument is yung in-emit ng sample in itself. Okay. Then we have the emission spectroscopy. Okay. So ano naman nangyayari dito? So ito medyo similar siya with the absorption, no? However, yung sample mo, ang ginagawa dito is sinusunog siya. Literal na sinusunog. Okay. So I don't know if may picture ako nun, pero ang tagal na kasi nun. 2018 pa ako gumawa ng thesis ko nun. Pero pakita ko sa inyo yung AAS. Flame, emission. Okay. So, ganito lang ginagawa dyan, no? Basically. Ito, ganito ginagawa dyan. So, yung sample mo, if you feed mo sa isang tube, which will be burned, no? Susunugin niya yung sample mo. Okay. Literal na sinusunog yung sample mo doon. Okay. So, there will be also incident light, no? And then the transmitted light, no? Okay. So, ganun din yung idea. Para siyang, ano lang din. Para siyang absorption lang din. So, dito yung incident light mo. And then, it will pass through the flame, no? And then, nandito yung transmitted light. So, gagawin ng computer is that it will compare the incident and the transmitted light, no? Okay, so yun yung i-detect ng ating detector. Okay. Also, take note na ang wavelength selector, instead na nandito siya sa left, napupunta siya sa right before the detector. Okay. So, before the detector yung ating wavelength selector compared sa kanina na katabi siya ng light source. Okay? So, yan. Pagdating sa emission, magkatabi ang detector pati wavelength selector. Okay? So, dito na lang niya finifilter yung many wavelengths of light. No? Ayan. Okay. Again, ang idea dito is that per element, may corresponding wavelength silang pinoproduce given by Niels Bohr atomic spectra. Okay? So, yun lang. So, yan. Siguro, tatanong ko yan sa inyo sa quiz. No? Identify the parts. Adi, yan. Alam nyo na. May kodigo na kayo. Okay? So, take note lang ng mga difference. Pag absorption, linear lang. Yan, andyan lahat. Ang wavelength selector nasa tabi ng source. Pag fluorescence, gawin mo lang perpendicular. Pag emission, yung wavelength selector mo, lagay mo sa tabi ng detector. Okay, so yan. Sa tingin nyo, bakit doon nilagay yung wavelength selector? Ba't hindi sa tabi ng source? Kasi take note, ito ay apoy, no? And yung apoy, it emits all of the colors halos, no? Halo-halo yung color na binibigay niyan. So, wala din, no? Kung i-select mo yung wavelength before the flame, no? Wala din, no? Kasi ang ilalabas nitong apoy is multiple colors of light, no? Multiple wavelengths. So, magkakanda halo-halo yung color pag dinetect yon. Kaya andito yung wavelength selector. Kasi nga, itong flame, halo-halo yung color na ini-emit niyan. No? So, to accurately measure certain wavelengths, mas maganda kung nasa right side yung ating wavelength selector. Okay? So, yan. Before the detector siya. Okay? So, yan. So, optical materials, ito naman yung mga glasses na ginagamit sa ito yung mga materials that are used in many types of spectrometry. Okay? So for example, if you are doing UV-Vis analysis, the materials that you need to use are ideally lithium fluoride, silica gel, or quartz, okay? Silicate glass or salts, no? Okay. So ito, hindi na natin 'to masyado di-discuss, no? Kasi ano naman 'to, masyadong chemistry na 'to, no? But the idea is that for each type of analysis, for example, you're doing UV or vis analysis, you should use select materials only. Kasi ang mangyayari if you select other materials is that they may interact with the light, no? Pwedeng mag-interact sila with the light, no? So ang result, ah, magkakaroon ka ng uncertainty sa measurement mo. Kakaroon ka ng noise, no? Ayan. So that's why we need to use specific materials only for specific measurements. Okay? So ang ginagamit namin sa UV-Vis ay typically quartz glass, no? In which ito ay napakamahal, sobra. So later on papakita ko yung cuvette, no. That is a quartz glass we use, no, sa UV-Vis Spectral Photometer. Okay. And actually it costs lots of thousands of peso, no. Anong nangyari kasi sa amin, before kami graduate, may nakabasag sa sa batch namin ng quartz glass, no. So I think that's 5 digits ata, no? I'm not really specific. I'm not really sure kung ano yung specific na amount nun. Okay. Maliit lang siya pero pag nabasag, super mahal, no? Kaya you really have to be careful with this one. Okay. Pero yun kailangan yun yung gamitin kasi if you use other materials, light may interact with the particles in the container, no? So magkakaroon ng errors yung inyong measurement. Okay? Kaya ayun. Kaya pag nasa chem lab kayo or magke-chem lab din naman kayo pag nag-work kayo, no? Ma-encounter nyo rin yung mga instrument na yan, no? So you really have to be careful, no? Especially kapag quartz glass yan. That is very expensive, no? Super mahal niyan. 5 digits yan. Mas malaki pa sa sweldo natin. Okay? So yan. So ngayon, let's talk about the light source, no? Kasi mapansin nyo, we always have light source, no? Whether that's absorption, fluorescence, or emission, we should have a light source, no? So ito yung mga ginagamit naming light source, okay? Each light source will serve certain purposes, no? Minsan pwede siya sa UV analysis, pwede siya sa visible light analysis, or pwede siya sa infrared analysis, no? Okay? So we will not go into much details, no? Daanan lang talaga natin to kasi hindi naman tayo BS Chem, no? Kaya daanan lang natin. Okay, so here are some types of light source we use, no? So one of which is the tungsten filament lamp. So basically, parang ito yung typical na bumbilya before, no? You have a tungsten inside, which is a metal. Okay? And when that metal is heated, it glows, no? Okay? So ito yung isa sa mga reason bakit nagtataka yung physicist dati. But kapag yung matter, ininit mo, nag-glow. Okay? So yan, as a result, ang dami nilang equation na binigay sa atin, which is inaaral ko ngayon na nakakaiyak. Okay. So anyway, so ito, tungsten filament lamp. Basically, you just have a tungsten filament inside, no? Pag nag-flow yung electricity dyan, it will glow, okay? And the wavelength it produces are between this range, 320 to 250, 2500 nanometers. So yan yung wavelength niya. So medyo malawak yung usage nito. So based on the wavelength, it can be used in the UV, visible, and IR analysis, no? So, pwede siya almost sa tatlo. But I think this is commonly used sa IR ata. Okay. So yan. Next one, we have a tungsten halogen lamp. Okay. So basically, parang ganun lang din siya kanina. However, ito kasi vacuum to, no? So there is no air inside to prevent the oxidation of the metal para hindi siya masira agad, no? However, ito yung isa naman, tungsten halogen lamp. So ganun pa rin siya. However, dinagdagan lang ng halogen gas dito. So the halogen gas added here is the iodine, okay? And the purpose of that is to prolong the life cycle of the lamp, no? Kasi itong tungsten filament lamp, mabilis to masira, no? Okay. Parang bumbilya natin yan, mabilis mapunde, no? So, para hindi yan mapunde agad kasi mahal yan. So, ginawa nila, naglagay sila ng iodine and apparently it prolonged the lifetime of the lamp, no? So, still, same pa rin yung wavelength, ano niya, same pa rin yung wavelength range, no? And it operates to higher temperatures, no? Kanina kasi 3,000 Kelvin lang. This time, it is 3,500 Kelvin. So, ibig sabihin, pag mas mainit yung kaya niya, mas malakas yung ilaw na kaya niya i-produce, no? Okay? So, mas malakas yung intensity of light that it can produce. Okay? Ayun lang, nilagyan lang ng iodine. Naging improved na siya. Okay? Next one, we have the deuterium lamp. Okay? So this is common in UV analysis, no? Ito medyo mahal talaga to. I think 5 digits din yung presyo nito pag nasira. Okay. Pero hindi naman to ginagalaw, no? So in deuterium lamp, basically you have deuterium. What is deuterium? Anyway, so what is deuterium? That is an isotope of hydrogen, no? So para siyang hydrogen gas but the isotope version. Okay, so we have deuterium gas inside and it glows then, no? Okay. So saan to ginagamit? If I'm not mistaken, UV analysis, UVVs, no? And then we also have this low pressure mercury arc lamp. So basically, the gas inside is the mercury, no? Pag ininit mo yung mercury gas, it glows, no? And this is used for HPLC or high performance liquid chromatography. What is HPLC? Discuss natin to sa asynchronous session natin, but this is used in laboratory to quantify yung molecules in the sample, no? For example, in drug testing, ito ginagamit HPLC. Okay. Ayan. Pwede rin gumamit ng GCMS, no? The gas chrome mass spectra. So basta yun yung mga ginagamit in quantifying mga molecules in our samples. For example, blood, no? Okay. So next one, we have the hollow cathode tube. Apparently, itong picture na to ay sira na. Okay. So ito medyo mura lang to eh. Okay. 5 digits lang din yan. Okay. So yan. So hollow cathode tube or hollow cathode lamp, HCL, tawag namin dyan. Ganon din. Instead of mercury, it has gas, no? Gas vapor ng atoms, no? Anong atoms? Ng elements na gusto mo i-measure. Okay, so may HCl for for copper. Ibig sabihin copper gas yung nasa loob. Nag-exist ba yon, sir, yung copper as as gaseous phase? Yes, no. Pwede mag-exist yung matter as gas phase. So gagawin lang nun is i-compress lang nila yon dito sa tube na to. And once it glows, it will detect the copper, no. Kunwari, gusto mo naman is lead, and may special lamp for lead, no. Kunwari, gusto mo zinc, may special lamp for zinc, no. Magnesium, may special lamp for magnesium. So basically, this contains the gaseous vapors of the metal. Okay. So this is used in AAS or Atomic Absorption Spectrophotometry. Glow bar naman, this is composed of silicon carbide rod, no? So parang lang tong 'di ba yung pencil kapag ininit mo yung carbon rod nun, nagkukulay pula din. Ganun din dito. However, instead of using carbon sa pencil, magkahalo yan, no? You have a silicon and the carbon graphite, no? So yan, it glows up to temperature of 1,500 degrees Celsius. So, kinukuryente lang yan para mag-glow yan. And that light is being used by various spectrometers, no? Also, we have the Nernst Blower. Oh, ayan, Nernst, no? Hindi siya pinangalan kay Nernst equation. So, ibang concept to. So, we have the Nernst Blower. So, dito naman medyo mahal to. So, you have rare elements embedded on the material. So, it is composed of zirconium and yttrium oxide. And when it is heated by electricity, it glows, no? So nag-glow siya, and that glow can be used as light source. Okay. So in summary, ito yung ating mga light source, ito yung wavelength region nila, and ito yung mga usage nila. Okay. So yan. And so take note that ang ating ito yung deuterium lamp, sabi ko sa inyo, ginagamit yan sa UV, no? Okay. And then some of them can be used in the visible. Okay. So pwede tandem yan, no? Pwedeng may deuterium pati tungsten lamp yan. Okay. Or pwedeng tungsten lamp lang meron. Okay. Pwedeng combination of the two. Okay. So yan. Itong IR naman, infrared, later kwento natin ano tong IR na to, no? Okay. So yan. Basta ang concept lang is dito sa UV visible, pwede mo to gamitan ng Beer's law. You can use Beer's law here. I think sa sa fluorescence, pwede rin yung Beer's law. Okay. So now, na-discuss na natin yung ating light source. Ano sunod ng light source? Yung syempre sample, then yung hindi. Mali. Nasa isip ko yung emission eh. Okay, so sa fluorescence pati sa absorption spectrometry, okay, you have the light source followed by the wavelength selector, also called the monochromator. Okay, pag sinabi kasing chroma, okay, chroma parang album lang ni sino ba may album? Taylor Swift ba? I don't know, hindi ako updated. So basta yun. So, yung pag-chromator, color yon, no? So, various colors yon. Okay? Pag sinabing mono, isang color lang. Okay? So, basically, our wavelength selector chooses a specific wavelength from the spectrum of light, no? Okay? So, in spectrum of light, ang daming color niyan, no? Pero, ang gagawin ng wavelength selector, choose niya lang yung iisang wavelength na gusto mo gamitin in your analysis. O, paano mo ba malalaman kung anong wavelength gamitin mo? Kung naalala nyo sa lecture nyo, diniscuss yung complementary colors, no? Parang balik kinder kayo nun eh. Okay. So malalaman mo kung anong color gagamitin mo by identifying ano yung complementary color. Okay. Ay, mali yung aking pagka-cut. wait lang. Ulitin ko ah. Wala ako sa eh. Not pala, ginamit ko na yung iPad ko. Wait lang. Okay. So, yan. So, hopefully nakwento to sa inyo ng prof niya, no? So, paano mo malalaman kung anong wavelength gagamitin mo? So, basically, you check kung ano yung complementary color, no? So, kunwari, kulay red yung object mo. So, ibig sabihin, ang wavelength na gagamitin mo is green, no? Okay? Kasi yun yung ina-absorb niya. Okay? So, yun yung ina-absorb niya. For absorption to, ha? Okay. So, kunwari, ang copper sulfate ay kulay blue. So, you will expect that it will absorb orange colors. Okay? Kasi kung ano yung kulay na nakikita mo, yung ina-absorb niya is kabaliktaran. Okay? So, ganun sa absorption spectrometry. Pero sa emission, hindi ganun na. So, medyo hindi niya sinusunod yung idea na yan. Okay? Kung ano yung wavelength na ina-emit niya, yun yung kailangan mo gamitin na wavelength. Okay? And given naman na yun, no? You can look up sa Google kung ano yung wavelength ng elements natin. That was established na naman. Okay? So in Wavelength Selector, we have two. We have Monochromator, meaning yan, iisa lang yung band of light na pwede niya i-allow. Okay? Small band lang. Okay, so ibig sabihin, isang wavelength lang yung kaya niya i-allow. And then we have Polychromator, or from the word itself, poly, ibig sabihin, maraming wavelengths yung pwede niya i-select. No? Okay? But not all. Okay? So yan. So ano ba nangyayari dyan? Remember, you have a spectrum of light, no? You want to choose only one of it, no? So isa lang gusto mo piliin, then, ayun, you use a monochromator, no? Okay, so para iisang wavelength lang yung magamit mo for your analysis. Okay? So anyway, we'll skip that. So, paano yung itsura ng monochromators? Basically, parang prism lang din yan. So you have your wavelengths, no? You have your light coming through. And then, through series of lens, okay, through series of lens inside the chromator, pwede mo ma-refine yung wavelength into one specific wavelength, no? Ito medyo physics yan, no? So this is the prism, parang ganito lang din yan, monochromator. The light will pass through it, and due to the properties of this lens, no, pwede siya ma-split into many colors. We'll not discuss this kung paano niya na-split yan into colors kasi physics na yung masyado. So, basta ang idea lang, based on the types of lenses you have, yun, you can split the colors. Okay? So, ito ganito rin dito. You have the incident light, then it will pass through this. Ito naman yung tsura ng grating. So, yung grating, mapapansin nyo, meron siyang mga, ayan, may mga pangil siya, no? So when the light passes, when the light hits that pangil, no, yan, pwede niya ma-select yung wavelength na gusto mo. So itong grating na yan, pwede yung gumanong ganon, pwede yung gumalaw-galaw. Okay. So depende sa paggagalaw niya, yung wavelength na lalabas from the setup, no. Okay. So yun lang. So ito may mga pangil siya, and yung mga pangil na yon, it will help to choose the wavelength na. Yan. So one example of grating, no? Makikita nyo yan sa CD, no? Yung CD may mga may mga mini pangil yan. Okay, pag ginilid mo yan, 'di ba makikita mo multiple colors, no? So and actually pwede mo gamitin yung CD in devising spectrometers, no? Ito yung ginagawa namin noong undergrad, no? Kasi yung prof namin, si Sir CJ, ang kanyang master thesis ay gumawa siya ng spectrometer na low cost. Ang ginamit niyang wavelength selector ay CD. No? Pwede gamitin yan. Kasi the CD can apparently diffract light, no, into different wavelengths. No? Ayan. Okay, so yan yung itsura ng gratings in a zoom in level. Okay. So other types of grating has to be concave, no? So instead of zigzag siya, concave sila. Okay. So yan, so kapag yung incident light tumama diyan, specific wavelength na lang yung tatagos. Okay? Then we have the holographic grating. Okay, so ang holographic grating is ultra refined na grating na kanina. Okay. So ito ay ultra defined, no? Mas maganda yung kanyang grating sa loob, molecular atomic level yung grating niya. Kaya yan, mas maganda yung kanyang performance. Basta ang purpose lang nitong mga grating na to is that it helps us to select wavelength lang. Okay? So, pinapakita ko lang mga iba't ibang uri ng ating wavelength selector. Okay. Sometimes gumagamit din tayo ng filters, no? The purpose of the filter is to minimize interferences, no? Okay? So ito na kwento natin last time, chapter 2, ano yung interference. Pag sinabing interferences, these are uh, things that causes error in our measurement, no? So since ang usapan natin dito ay light, no? Maraming interference sa light, no? Pwedeng stray light, no? Yung liwanag ng paligid makaapekto sa measurement mo. Okay? So in order to minimize that, we use filters, no? So these filters are used to minimize the presence or the interference of stray light or other light sources, no, na hindi mo gusto in your measurement. Okay. So ito yung itsura nila. Parang sa parang sa microscope, no. Sa microscope, 'di ba, gumagamit tayo ng filter sa ilalim, no, so that we can see clearly our sample, no. Okay. Saan nyo ba ginagamit yan? Sa inyong nakikita ko sa yung nakikita ko sa mga post nyo? Yung pag nag-staining kayo, 'di ba, minsan kailangan niyo ng filter. Ganun din sa ganun din sa spectrometers, no. Kasi again, no, yung light masyado siyang masyado siyang broad, no. Okay, pwedeng maghalo-halo yung colors doon. So if you want to minimize the mixing of light, you use filters, no, other than the wavelength selector. So sa naman, sa IR spectroscopy, discuss natin to later. Instead of using colored filters, we use what's called the interferometer, no. Okay. So ang interferometer naman, ang pinoprohibit niya is yung mga electromagnetic waves na undetected by the eyes, especially yung mga infrared light, no. Okay. So apparently tayo kasi we also emit infrared light, no? Kasi mainit tayo, no? So if you use certain equation, especially the Stefan-Boltzmann equation, pwede mo ma-detect yung wavelength na ini-emit ng tao. Okay? So totoo ba 'yon? Totoo 'yon. Kasi sa thermal scanner, 'di ba napapansin nyo yung tao nag-glow. Kasi nag-glow talaga tayo. Di lang natin nakikita. Okay? So if you use IR spectroscopy, yung glow ng tao nakaka-affect 'yun sa measurement, no. So to minimize that we use interferometer, no. So siya yung nagka-cancel out ng other infrared rays emitted even by people. Ayan. And yan. So asan na tayo? So we discussed the light source. Okay, so alam na natin yung mga light source. We have the tungsten halogen, no? The hollow cathode tube, hollow cathode lamp, no? We have the deuterium, we have the mercury vapor, no? So tapos sa naman sa wavelength selector, na-discuss natin yung mga monochromators, no? Yung mga gratings, no? Okay, so basically prism lang sila, pero maliliit na prism, no. So ngayon naman, let's talk about detectors, no. So from the word itself, detectors detect the transmitted light, no. Okay. So it detects kung ganun na lang karami yung na-transmit ng sample mo. Okay? So ang detector ay may kasamang transducer, no, for spectral photometers, no. And the transducers convert yung light into kuryente, no? Okay? So, kino-convert niya yung light into electricity, no? Okay? And these are the different types of detectors we use in spectrophotometers. Okay? So, for each detectors, there is a certain wavelength used, no? Okay, so yan. For example, if you're doing UV analysis, pwede na yung phototubes, photomultiplier, yan. Pwede na yung mga yan. But if you are doing infrared spectrometer, higher wavelength yon, then you need other types of detectors. So ito, mga photon detectors, pwede to sa fluorescent or absorption. Pero kapag emission, pwede rin pala to, no? Pero kapag IR, ito yung gagamitin mo, thermal detectors. Okay? So basically, lahat na may mga kulay, even the ultraviolet, pwede dito. Pero kapag mga infrared rays na, you use this, no? Okay? So yan. So alam niyo na yung idea kung ano mangyayari sa multiple choice, which can be used in UV analysis. Hanapin niyo na lang kung asan siya. Pag thermal detector yon, di pwede yon. Photon detector lang pwede. Okay? So yun lang. Discuss natin sila briefly, ano itsura nila. Pag phototube, it uses the concept of photoelectric effect. No, this was discovered by Albert Einstein. Actually, hindi discovered, explained by Albert Einstein. Okay, so iba nga pala yung naka-discover niyan. So this was explained by Albert Einstein. Ano ba nangyayari sa photoelectric effect? No, when certain wavelength passes through a metal, the metal will release the electron. Okay. Yan yung photoelectric effect, no? So kapag naglagay ka ng light sa metal mo, yung electrons ng metal tatalsik daw. Okay? That's the photoelectric effect. So mangyayari dito is ganito. Given that yung ating liwanag, pwede niya mapatalsik yung electron ng ating metal. So we have here the cathode, this is the metal. So kunwari ito yung ating transmitted light. Pag tumama yan doon, tatalsik yung electron. And then when the electron goes to this anode, no, ano mangyayari? May circuit ka, may voltage yan. Pag yung electron from the cathode tumalsik doon, may certain voltage yan. Okay? And that voltage can be determined by the transducer, no? It can be converted into a readout, no? Pwede niya ibigay yung result, no, as a number. Okay, so ganun lang yung idea dyan. No? So you have your incident light, tatama siya sa metal. Then, according to photoelectric effect, yung ating light, pag tumama sa metal, yung electron ng metal tatalsik. No? And when the electron jumps from the cathode to the anode, apparently there is a complete circuit. No? May voltage reading dyan. Okay? So ganun ginagawa nila dyan. So that's the phototube. And so by the way, the current that we produce here is specifically called the photocurrent. No, that is the current induced by photoelectric effect. No, so we have to be specific. Photomultiplier tube has the same concept. No, so yung word na multiplier, ibig sabihin pinaparami niya yung liwanag. Okay. So, ibig sabihin you have series of metal frame doon. 'Di ba? Sa phototube isa lang. Sa photomultiplier tube, sobrang dami. Okay. So, sobrang dami ng inyong electrodes doon. So, when the light passes through that, no, pwede sila mag-bounce diyan. As a result, mas magiging sensitive yung instrument, no. Mas malakas yung kanyang sensitivity. So, it can measure smaller concentration. Okay, so anong difference? Phototube, isa lang. Pag photomultiplier, maraming cathode. No? So as a result, yung light pwede mag-bounce doon. And as a result, mas mataas yung sensitivity ng instrument because it can detect light. No? It can increase the intensity of light. No? Okay. Another detector is called the Photoconductive Cell. Okay. Medyo similar to with the phototube, no? Yung phototube kasi yung pinakaluma talaga, no? Kasi ito yung mga bago, no? So ganun din dito for photoconductive cells. As you can see, mas maliit siya, no? Kasi mas advanced nga to. But instead of using typical metals, ang ginagamit dito ay film of semiconductor. So hindi na metal gamit dito, semiconductor ang ginagamit dito. So these are the semiconductors used in the photoconductive cell. Okay? So same concept pa rin, pag tumama yung liwanag dyan, yung electron gagalaw. And pag gumalaw yung electron, may voltage reading. Kaya important yung electrochem, no? Silicon photodiodes, ganun din to. Ito yung nasa camera natin, no? Ito yung nasa camera natin. So, kung bubuksan nyo yung mga iPhone nyo or mga cellphone nyo, basta yung camera nyo, in the end, meron yung sa likod ng lens, meron yung photodiode. So yung light tatama doon, and then yung electron gagalaw-galaw. So as a result, may voltage, no? And what happens is that yung ating cellphones, no, they convert that electrical voltage into pictures. Okay? So ganun nangyayari. So ang galing, no? Even sa cellphone natin, meron tayong spectrometers, no? May part tayo ng spectrometers yan. Okay. So silicon photodiodes, hindi lang to ginagamit sa spectrometers, ginagamit din to sa cellphones, no? Yan yung nakikita nyo sa likod ng camera. Okay. Kung gusto nyo mag-ensure, pakita ko sa inyo iPhone photodiode. Ito. Kunwari ito sa iPhone 12. Ayan. So, yun yung kanyang sensor. That sensor is typically photodiode. Photodiode yan. So, yung light tatama dyan, then ko-convert niya into kuryente. Then, the computer will convert that into a picture. Okay. So, ganun. But in analysis of, sa UV analysis, hindi niya ginagawang picture yon. Ginagawa niyang number yon. Kino-convert niya into absorbance. Ayun lang. Okay, so pag IR naman, again, iba yung concept ng IR kasi infrared radiation is a form of heat, no? Init yan eh. Kaya nga sabi ko tayo nag-glow because we are literally mainit, no? Okay, so yan. So in thermal detectors, such as yung ginagamit sa airport or sa mga thermal scanners sa mall, sa LRT, so it uses thermal detectors, no? So medyo same concept siya, iba nga lang yung design, no? Okay. So iba nga lang yung design niya because it is designed not to use not to use visible light, no? Rather to use IR, no? Yung IR yung tatama sa kanya. Yan. So yun. So balik tayo sa sample. Sa UV-Vis, ito yung sinasabi kong cuvette, no? So sa UV-Vis, ilalagay mo yung sample mo dito and then the light will pass through that, no. Ito yung letter B sa ito yung letter B sa Beer's law. Okay. Remember A, absorbance equals epsilon B C. Yung C is the concentration, the B is the path length. When we say path length, we are pertaining to the length of the cuvette. Okay? Kasi mangyari dyan, yung light, tatama yan doon. Okay? So, this is the incident light, and this is the transmitted light now. So, yan. So, kung mahaba tong length mo na to, mahaba yung cuvette mo na yan, mas malaki yung absorbance na. Pag mas maliit yung cuvette mo, mas mababa yung absorbance na makukuha mo. Okay? So, yun yung idea dyan. No? So, yung cuvette, dito natin nilalagay yung ating samples. No? Yan. Typically, this is made of silica glass, no? Silica yung ginagamit, which is, sabi ko nga, super expensive. Yan, super expensive, mga 60,000 ata isang ganyan, no? Kaya yun. So, you really have to be careful when handling this. Okay? So, ito yung mga iba't ibang uri ng ating, cuvette. Okay? But the common one is this one. Yung open top, no? So ito yung ginagamit namin madalas. But there are other types of cuvette available in the industry. Hindi kasi ako nag-work sa industry kaya ito yung common lang alam ko. Okay. Academe kasi ako. Pero yung mga nag-work sa industry, yung mga nag-work sa mga sa mga processing plants, no, sa mga chemical analysis lab, iba yung ginagamit nila. Okay? But the idea is that it will hold the sample and then may certain may certain opening, no, para dun tumagos yung incident light. Okay. Ayun, medyo malapit na tayo matapos, no. UV-Vis instrument, so we have the spectrometer. Basically, pinagsama-sama lang natin, no? Pinakita lang natin on a bigger detail yung diagram earlier, no? So you have your light source, you have your wavelength selector, then it will pass through the sample, then it will have the detector, and the transducer will convert that into numbers, no? Okay. So ito lang yung bigger view ng ginawa natin kanina. Okay? So yan. So a spectral photometer, so from the word itself, it is a meter that detects spectrophotos, no? So dinedetect niya yung mga light, no, that is emitted or absorbed by the sample. Okay? And it is used in UVVs. No? Ang photometer naman, this is similar with the spectral photometer. Okay? However, pag photometer, specific yung light na dinedetect niya lang. Okay? Specific light lang. Okay. So we have two types of UVVs. We have the single beam and the double beam. No? So ano yung pinagkaiba ng single beam and double beam? So kapag single beam, let me show you the diagram. Pag single beam, isa lang yung yung light source mo, yung beam niya, yun lang yung gagamitin. Tatagos lang yun. So single beam, isang straight line lang yung magagawa mo from the source to the detector. Okay? Kaya mapansin nyo, mahaba yung mga single beam, no? Ito yung mga luma, no? Mga luma to eh. So isang direktong lang yan, setup, wherein nandito yung light source, ito yung sample, dito yung detector. So isang straight lang yan, kaya medyo mahaba yan. However, since luma yan, no, medyo hindi na yung ginagamit, we use the double beam na. This is more advanced, no? And siya. And better siya than the single beam, okay? Okay. So ito yung itsura ng double beam. Okay, sa mapapansin mo, after the monochromator, the beam will be split into two, okay? So iba yan kanina. So ito is dire-diretso lang, no? Gagawin mo, papalitan mo na lang yan. Ayun, palit-palit ka. Pero kapag double beam yan, okay, it measures two at the same time. No? Dalawa yung mini-measure niya. Okay? So dalawang cells yung mini-measure niya, dalawang cuvette yung kaya niya basahin. So what will happen is that after the wavelength is selected, no, you will have this thing called the beam splitter. So split niya yan into two. The one will pass through the reference cell. The one will pass through the sample. The reference cell is typically called the blank. No? This is the blank. Ano yung nilalagay namin dyan? Yung solvent. So that's typically the blank which contains the solvent. No? So dyan namin nilalagay yung solvent. Pwedeng tubig lang yan. Kaya kung hexane ginamit mo, nilagyan mo yan ng hexane. No? So yan, the purpose of adding the blank in the measurement is to correct the readings. No? Para mas correct yung readings natin. To minimize the errors. No? Okay, kasi sometimes yung ating solvent, they can absorb light as well. No? Pwede rin sila mag-absorb ng light. So magkakaroon ka ng error sa measurement. Okay. So for double beam, ganito yon, no? So you have your source. After it is filtered, split yan by the beam splitter. One will pass through the reference, one will pass through the sample. So sa reference, andito yung blank. Typically, solvent lang nilalagay dyan, no? And then yung photodetectors, dalawa din. And then gagawin nun is isusubtract niya itong transmitted at yung incident. So isusubtract niya yan. Then makukuha niya yung absorbance. No? Okay? So gagamitin niya yung equation na dito na ginagamit yung dito sa part na to. Dito na ginagamit yung equation na absorbance equals negative log P over P naught. Okay. Ayan, di ba? Nasa lecture niyan. Negative log P over P naught. No? Okay, or the P is the transmitted, the P naught is the incident. Okay. So we also have what's called the double beam in time. So basically, ang nangyayari dito is that yung mirror ay umiikot-ikot. So umiikot-ikot yung mirror mo dyan. Okay. So I haven't encountered this in person, no? Kaya wala akong medyo masabi dito. But the idea lang here is that yung ating mirror ay umiikot-ikot siya. Okay. So I'm not really familiar saan to ginagamit, no? But kailangan paikutin yung mirror. But this is the typical thing that we use in the laboratory naman. So pag pag nag-analysis kayo, gagawin nyo rin to, no? Pag nag-medtech na kayo. Pag medtech na kayo, gagawin nyo rin yan. So you have to be familiar, no? So baka kasi pagkabukas nyo magtaka kayo, uy, bakit dalawa lalagyanan? Dalawa lalagyanan kasi yung isa reference, yung isa sample cell. Okay? So yan. So let's talk about IR, no? So pag IR naman, this is the thing we use to determine the components of the molecules, no? Okay? So kunwari you have a compound, you can determine ano yung mga functional groups in there, no? Okay? So kunwari you have this compound, saan na yung mouse ko? So, suppose you have this compound, pwede mo ma-detect yung functional groups ng ating compound using IR, no? So, ginagamit namin to identify anong type ng molecule kaya ito. Okay? So, yun yung ginagamit namin, no? So, ginagawa nito sa IR, it uses the concept of the motion of the bonds, no? So, mangyari dyan yung IR, pag tumama yan dito, asan na yung cursor ko? Yung IR, infrared rays, no? Pag tumama yan dyan, what will happen is that the molecule will vibrate, no? So yan, depending on the vibration of the molecule, ganitong graph mapoproduce mo. Okay? So yan, so from this graph, we can interpret different functional groups, no? So, dati kabisado ko to, ngayon hindi na. Kailangan kabisado to nung undergrad. Okay, so for example, at this peak, you have the carbonyl group, no? And then on this part, you have your alkyl groups, no? Ayan. So, yan. Hindi na natin di-discuss to, no? So, ang idea lang dito sa IR spectrometers is that we use this to identify the functional groups in your molecules, given that yung ating bonds, they vibrate, no? Nagva-vibrate sila at different wavelengths as well. Okay? So, ito yung setup ng IR. Ganun din. Medyo similar siya with the absorption spectrophotometers. Okay. And this is the more advanced type of IR, which is the FTIR, the Fourier transform. Okay. So, ang nangyayari lang dito is that it compares itong stationary mirror, gumagalaw-galaw lang yan, no? And depending on that movement, pwede siya gumamit ng calculus, no? So yung computer mismo yung gumagawa ng calculus to interpret that into something usable, no? Okay. So medyo complicated yung process dito. Basta ang idea lang is that yung light, no? So marami siyang tatamaan. So gagawin ng instrument is that it will compare all these other measurements, no? Ko-compare niya lahat yan. Okay? So by comparing them, pwede mo malaman yung functional groups. Okay? So di na natin to discuss. Too complicated na yan. So saan ginagamit ang spectrophotometry, no? So maraming uses to, no? Especially sa field ng sciences, biology, health sciences, no? Chemistry, biology, physics, ayan. Even food technology, nutrition, medtech, no? Nursing, medicine, lahat tayo gumagamit ng UVVs, no? Spectrophotometers, no? So we can use this to quantify many stuff, no? Sa chemistry, ang kina-quantify namin using sa spectrophotometers generally ay mga metals, enzymes, no? Mga nucleic acids, no? So, yan. So you can determine their amount, no, by using UVVs, no. Okay, so sa nucleic acid, pag nag-biochemistry kayo, madidiscuss uli ito, no. So ayan, you will just compare two wavelengths, no, and then from that you can determine the amount of nucleic acid in your sample. So marami tong application, no. So other than quantification, this can also be used in optimization of drugs, no, optimization of enzymes, no. So yan. My classmate now worked on a thesis which focused on the ano, which focused on the enzyme activity of enzyme activity ng isang plant, no. Ayun. So to determine the enzyme activity of that plant, no. Ayun. Gumamit siya ng UVVs, no. So hindi lang siya limited to determining the concentration of metals, so on and so forth. Pwede nyo ito magamit sa biochemical applications. Okay? So, yun. So, more of this will be naman, mas marami kayong ma-encounter nito kapag nag-work na kayo, no? And apparently, kasi since online class tayo, lahat ng ito ay idea lang muna, no? Pero hopefully, pag nag-work na kayo, na maalala nyo pa tong mga pinagsasabi ko. Kasi pag nakakita kayo ng UVVs, kung ano yung dinescribe ko, yun talaga yung itsura nun, no? Kasi gumagamit ako ng UVVs. Okay? So hopefully, yun, may natutunan tayo today. So we're done with our discussion. So ano yung takeaways natin? Ang takeaways natin is number 1, ang ating sige, picture tayo. Mamaya na. Ang takeaways natin dito is ang spectral photometer important sa ating field because this can actually help us in quantifying substances. No? Marami tayong pwedeng magawa dito. Quantification, identification ng elements, no? Or even functional groups. No? So yan, na-discuss natin yung maraming parts niya. So yan yung mga parts. Yung mga in-emphasize ko kanina, kapag fluorescence, 90 degrees dapat, no? Remember that na lang. Okay? So apparently, ang magiging quiz nyo dito ay puro multiple choice. May mga free response, no? So, yun. Wala na tayong problem solving. So, thank you, Lord, for that. Naka-survive na rin kayo. Okay. So, ayan. So, thank you for attending our last session. Picture daw. Maybe I will end the recording para hindi nila makita mukha natin.